Let's go ahead and go over the launch for let's go ahead and go over the launch for today. So Ms. Chan has started to run again as a way to improve her heart's health. She wanted to test whether Nike or Adidas would make her run further in the same amount of time. Ms. Tran ran for 30 minutes each day for 10 days and measured that she ran an average of 1.8 miles with a standard deviation of 0.8 in her Adidas shoes. She then ran 30 minutes each day for another 10 days to measured that she ran an average of 1.5 miles with a standard deviation of 0.5 miles in her Nike shoes. Part A says, would you consider this a two sample means test or a matched pair design? Explain your thinking. So remember that a matched pair design, and this is something I'm going to write on the side for some notes. A two sample means represents that we have two population and we're pulling a sample from each of these two populations. For a matched pair design, you have one population that tests both treatments. So in this case, we're actually doing a matched pair design. And this is because you have one person, which is me, testing both treatments. So there's only one person who tests both treatments, which is the Adidas versus Nike. So if I'm doing a matched pair design, essentially I'm doing a one sample means, and I'm using that equation instead of the two sample means equation. So assuming that the conditions for inferences have been met, construct and interpret a 95% confidence interval for the difference in miles ran between the Adidas shoes and the Nike shoes. So if we think back, right? So first, this is a matched pair confidence interval. If we think back to unit 5 when we did hypothesis test on means, or unit 6, when we do a matched pair design, you take mu difference. You use mu difference as your parameters. So here we're going to use mu d, which means mu difference, represents the difference in miles ran in 30 minutes between the Adidas and Nike shoes. Okay. Now, to do the math, right, we need to find X bar D and standard deviation D. And standard deviation D. So X bar D is just equal to X bar 1 minus X bar 2. So in this case, it's 1.81 minus 1.5, which is 0.3. For standard deviation, this is the square root of S1 squared over N1 plus S2 squared over N2. And in this case, this is the square root of 0.8 squared over 10 and 0.5 squared over 10. So this is equal to 0.197. Okay. So we have our equation x bar d plus or minus t star times the square root of sd squared over n. I'm just going to put this into the calculator. So I'm going to go to stat, test, t-interval, because remember this is a one sample t-test because we're doing a difference. I have 0.3, 0.197, sample size is 10, and my 95% confidence level. And I get my interval to be 0.159, comma 0.44. T star, if you wanted to do this by hand, T star is going to happen at degrees of freedom 9, comma 95. So what's our conclusion? We are 95% confident that the true mean difference in miles ran in 30 minutes between Adidas and Nike shoes is captured in the interval 0.159, comma 0.44. Okay. So we are 95% confident that the true mean difference in miles ran in 30 minutes between Adidas and Nike shoes is captured in the interval of 0.159, comma 0.44.